Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the question number 11 and 12 of chapter 12 electricity NCERT class 10 CBSE. Okay, so the question number 11 says show how you would connect three resistors each of resistance 6 ohm so that the combination has a resistance of 9 ohms, and in the second case it is having the combination of 4 ohms. So we need to find out the combination. How should the three resistors having the resistances equal to 6 ohm should be connected in the combination of 9 ohms and 4 ohms. So we know that the resistances are connected in two ways. Either they are connected in series or they are connected in parallel. In the series, the current remains the same and the equivalent resistance is given by the directly addition, the summation of all the resistance values. But in the parallel, the current gets divided and the voltage remains the same, and in the parallel circuits, the equivalent resistance is found out by taking the reciprocal and then adding them. Okay, and again we need to do the reciprocal in the end in order to get the equivalent resistance value. Okay, so how would the three resistors having the resistances 6 ohm should be connected so that we get a combination of 9 ohms. So let us draw over here and see whether the circuit, whether the resistance combination that we have drawn is giving us the value 9 ohms or not. Okay, so first of all, let us draw like this. So here two 6 ohm resistors having the resistance 6 ohms is connected in parallel, and the equivalent parallel is connected to the 6 ohm resistance in series. Okay, so first of all, let us find out R equivalent. So R equivalent will be equal to Rp plus 6 ohms. Okay, because this whole combination is in parallel and this whole combination is connected in series with this 6 ohm. So the R equivalent will be equal to Rp plus 6 over here. Okay, so Rp, in order to find out Rp, we need to apply the parallel formula for the resistances. Okay, so 1 upon Rp will be equal to 1 upon 6 plus 1 upon 6. That will give us 2 upon 6. It will get cancelled out. 2 ones are 2, 2 threes are 6. So Rp, 1 upon Rp will be equal to 1 upon 3, which would give us Rp value to be equal to 3 ohms. And R equivalent is given by Rp plus 6. So Rp is 3, 3 plus 6 will give us 9 ohms. So this combination is suited to give a combination value of the resistance equal to 9 ohm. Okay, so this is a suited value. Okay, so now let us find out the combination of the resistances having the value 6 ohm to be connected and getting the combination value as 4 ohm. Okay, so let us draw the circuit. If we connect a resistor, two 6 ohm resistances are connected in series and the left out 6 ohm is connected in parallel with it. So this forms the series circuit RS. Okay, here it was Rp, but here it is forming the series circuit. Okay, so let us find out R equivalent in the second case. So here R equivalent will be equal to Rs parallel to 6 ohms. Okay, it will not get directly added up because they are not in series, they are in parallel. They are having the parallel combination. So Rs will be equal to R equivalent will be equal to Rs parallel to 6 ohms. So here Rs, because both of them are in series, So they get directly added up equal to 12 ohms. Now R equivalent will be equal to 12 ohms parallel to 6 ohms. That means 1 upon R equivalent will be equal to 1 upon 12 plus 1 upon 6. So when we take the LCM as 12, we will be getting over here 1 plus 2. Okay, so 1 upon R equivalent will be equal to 1 plus 2 upon 12, which will be equal to 1 upon R equivalent will be equal to 3 by 12. This gets cancelled out. 3 ones are 3, 3 fours are 12. So ultimately R equivalent is equal to 4 ohms. So this combination only we need to find it out over here, that the combination should give us the value of 4 ohms, and this combination is giving us the value of 4 ohm. So they have asked in the question to show that how you would connect the 3 resistors. So for getting the combination of 9 ohm, we need to connect 2 resistors having the resistance value in parallel, and then it should be connected in series with the left out third resistor. And in order to get the value 4 ohm, the 2 resistors having the value of resistance 6 ohm should be first connected in series, and then it should be connected in parallel with the left out third resistor. Okay, so this is also suiting our the value is being suited with this combination. So these combinations are appropriate according to the question. Okay, so now let us move on to the question number 12. The question number 12 says, several electric bulbs designed to be used on a 220 volts electric supply line are rated 10 watts. How many lamps can be connected in parallel with each other across the 2 wires of 220 volt line if the maximum allowable current is 5 ampere? If the maximum allowable current is 5 ampere. So the electric bulbs are designed to be used on a 220 volts electric supply line of rating 10 watts. Okay, so we already know a formula that P will be equal to V square upon R. So from here we can easily find out the value of R to be V square upon P, which will be equal to V square is given by 220 square upon 10. Okay, so 220, this will give us 220 into 220 upon 10. That means 220 into 220, 22 into 22 and 1 with 1 0. So this will give us 4840 ohms. This will give us 4840 ohms. Now the resistance value, the resistor having the value 4840 is to be designed. It is designed, this much value of resistor is designed and is to be connected in parallel with each other. Okay, so we need to find out how many such resistances should be connected. Means this is a supply line, and the supply line is having a 220 volts supply line, and it is having the current of 5 amperes. Okay, it is having a current of 5 amperes. Now between these two lines, how many resistors should be connected, having how many should be connected, having each of them having the value to be 4840 ohms, having the value 4840 ohms. So let us first find out the equivalent resistance value. So the equivalent resistance value can be calculated according to the Ohm's law. Ohm's law is given is equals to V is equals to IR. Okay, Ohm's law is given by V is equals to IR. So R will be equal to V upon I. So V is 220 and I is given as I is given as 5. Maximum allowable current is 5. So we'll be getting over here 44 ohms. So 44 ohms is the equivalent resistance value of 4840 to be connected in parallel. Okay. So how many such lamps or bulbs should be connected in parallel of having the value 4840 ohm, so that the equivalent is we have equivalent resistance value to be which we are getting is equal to 44 ohms, and the maximum allowable current is 5 ampere, and the maximum allowable current is 5 ampere. So because they are connected in parallel, so we would be applying the parallel formula for the resistance combination. Okay, so applying the parallel formula, we will be getting over here 1 upon 44 to be equal to 1 upon 4840 plus 1 upon 4840 plus 1 upon 4840, and we don't know how many, so it will go n times. Okay, so let us assume that the number of lamps to be equal to n. So let us assume number of lamps equal to n. Okay, let us assume this number of lamps equal to n. Okay, so n times, so this n value only we need to find out how many lamps could be connected in parallel, so that we are getting an equivalent of 44 over here. So because they are added up n times, so we can directly multiply it by n. So 1 upon 44 will be equal to n into 1 upon 4840. So when n is to be calculated, 4840 will go that side, and it will come with the multiplication over here. So 1 upon 44 into 4840. So it will go 1 times, carry of 4, again 1 times, and 0. So we'll be getting over here, therefore number of lamps, okay, we will be getting from here 110. So therefore the number of lamps which are connected in parallel across the two wires of 220 volt line, then if the maximum allowable current is 5 amperes between the two wires of 220 volt line are 110. Okay, so the answer is 110. So in this manner, we need to find out how many lamps are connected in parallel. So the number of lamps connected in parallel between the two wires of 220 volt line are 110. Okay, the concept here which we used over here was that we know that power is equals to V square upon R. So because in the parallel circuit, the voltage remains the constant. So the power formula which we applied was V square upon R, and so R is equals to V square upon P. So first we found out the value of one resistance, the resistance value which is to be connected in parallel. So it came out to a 4840. Then by Ohm's law we found out the equivalent value of the resistance. What is the equivalent value of the resistance? And we know that the equivalent value of resistance will be equal to 1 upon 4840 plus this up to n times, because we don't know n and we need to find out n from here. And then we just calculated it and we found out the value of n, and it came out to be 110. So in this manner, we need to solve the questions. In the next session, we will be solving more of the numericals of this chapter. So thank you. So please subscribe my channel, and if you have any doubt, you can ask me in the comment section. Thank you.